Hello everyone, and welcome to another discussion of data structures and algorithms. And in this video, I'm going to talk about searching algorithms. Now, whenever you want to develop a software or an application, and if that application comes with a search feature, then you have to implement the right type of search algorithms. You have to implement the proper and the right type of searching algorithm for that particular search feature. This is especially true to applications. It actually depends to the size of the application or software that you're going to develop, and there is a right searching algorithm for every type of application that you are going to develop. And there are lots of searching algorithms out there that you can try and you can implement in your software. But in this video, I'm going to talk about the three common and popular searching algorithms, especially with people or students who are fairly new to searching algorithms. Now, these three searching algorithms are, again, quite the popular ones and quite the common ones because they're easy to understand, especially to the people who are fairly new to searching algorithms. Now, I have linear search, a binary search, and interpolation search. Now, let's go first with linear search. Linear search, again, from the word linear, it's just performing search in a linear fashion. So, if I would give an example, let's say you have an array, you have a group of array here. Let's say I have, okay, let me just change the color. Okay, so let's say I have an array here. Let's say this is index 0, 1, 2, 3, and 4. So I have 5 indices here that starts with index 0 and ends with index 4. So let's say that for each index I have, let's say, random values. So I have, let's say, 5, 1, I have 6, I have 0, for example, and I have 7. So if I'm going to perform linear search, then the algorithm says that you have to start with the very first index number, which is 0. So let's say I'm going to search for a key value. So the one that you're searching, the value that you're searching for, we call that the key value. Okay, so let's say my key value, the one that I'm looking for, is, let's say, 6. Okay, I'm looking for 6. Now, this value would be compared to the first value of the first index. So it starts with 5. Is 6 equal to 5? No, and then it moves to the next index number, which is 1, and it will be compared. This value will be compared to the value inside index number 1, and so it's not. And so if this one comes to a point that the content of this index number is equal to this key value, then the search would return true. For example, it means that the key value is found among these values in the array. So that is how linear search works. Okay, and the second one would be binary search. Okay, so we're through with this. And binary search is, we also call that binary search. Binary search. We also call that the divide and conquer. The divide and conquer approach, because basically if let's say I have an array, I'm going to divide that array into half until such time that the range would be lessened, and the value that you'll be searching for would be encased, quote and unquote, in that certain range. So if I may give an example. All right, so let's say I have this array. Okay. Let me give an even number of values of array. So let's say I have 6. I have 6 values. I have 6 indices for this array. So I have index 0, 1, 2, 3, 4, and 5. Now, remember that whenever you're performing a binary search, okay, it is very important that the values here in your array should be sorted, okay, meaning the values should be arranged in a manner, let's say ascending order or descending order, okay. It is very important to be that way, because you are comparing the key value with the one that you're searching, if it's less than or greater than. So let's say I have 2, 4, 6, 8, 10, and 12. So let's say the one that I'm looking for is 4, for example. Okay. Now we have to divide this value into 2. We are going to look for a midpoint. Okay, but since this is even, then for example, I'm going to look for this key value over here. Okay, so this is our key value, and these are our index numbers, our indices. So let's say I'm going to look for this value 4. Now we have to look for the midpoint of this one, the index 0 and index 5. Okay, now we have to add this. So 0 plus 5 would be 5. And then we divide that by 2 to get the midpoint. So we have, let's say, this is 2.5. But there is no index number 2.5. So if in your code you set this to integer, then chances are the fraction here would be ignored, and the value would be the integer 2. So you will be looking for the match of 4 here in index 2. So 4 will be compared to 6. Okay, is 4 equal to 6? Definitely not. It's not equal to 6. So where is 4 going to be compared to next? Is it going to be compared to index 3, or compared to index 1? It depends on the comparison. So if 4 is less than 6, okay, 4 will be compared to the left index. If 4 is greater than 6, then it will move to the right index, to index 3. But since 4 is less than 6, then this value here will be compared to the content of the left index, which is 1. Okay, so we now move on with 4, and what that means is this index 3 until index 5 will be totally ignored. Okay, the algorithm will just focus on index 0 and index 1. So let's now compare 4 with the value of index 1. So is 4 equal to 4? Definitely yes. So we found a match, and the algorithm will stop there. Okay, now since we are comparing less than or greater than with the one that we're comparing the key value with. It is again very important that your binary search algorithm should be implemented in values that are again sorted. So it is very important that before you perform binary search, your values should be sorted. Okay, it doesn't matter if it's in ascending order or descending order. The important thing is that it is sorted. Okay, so that's binary search for you guys. Now let's move on with as a challenge for you guys, determine what will happen if, let's say, these values are not sorted. So for example, I have random values here. Let's focus with the same values here. So let's say that instead of sorted values, I have, let's say, 6 to 12, for example. I have 4, and then 10, and then 8. So let's say that I'm going to look again for 4. Okay, now I have the same index numbers. So this is index 0, 1, 2, 3, 4, and 5. So since we have the same number of indices, we get the midpoint, the same midpoint of 2. Okay, so 4 would be the value 4. Since we're looking for 4, then this value here would be compared to the value of index 2, which is 12. So is 4 equal to 12? Definitely not. And we compare the value of 4 with 12. Is 4 less than 12? Definitely yes. So we move to the left of the array, which means that 4 will be compared next to the value inside index 1, which is 2. Right. So is 4 equal to 2? Is 4 equal to 2? Definitely not. And we compare again 4 with we again compared 4 with the value of 2. If it's less than or greater than, it's greater than. But the problem here is we're done with this. We're not going to look further with the right side. That's how binary search works, and therefore 4 would not be found. Your search would produce a logical error. Definitely there's 4 here, but it's not found because your values are not sorted. So always remember that when you perform binary search, you have to remember that the values should be sorted first. Okay, and next we have interpolation search. Interpolation search is sometimes referred in other textbooks as extrapolation search, and it doesn't matter if we use the term extrapolation and interpolation. They actually perform the same algorithm. Okay, so what's the difference between binary search and interpolation search? Actually, they're kind of the same. Binary search and interpolation search. Interpolation search is also divide and conquer, but the main difference is, think of it like this way. All right, if let's say I have a value here, let me just have a value here. Okay, I'm looking for, let's say, key value of x. So again, we get the midpoint of let's say this range, the midpoint of this range, and the midpoint is over here. So x would be compared to the value of this range, of whatever the content of this one. And if it's not found, then the algorithm will kind of estimate the location of the one that we're looking for. So Again, just like with binary search, the other part will now be ignored. So this one will be ignored, and it will focus on this part. But it's not actually going to look for the exact midpoint, but it's going to kind of estimate the location of the perceived match of this key value. So it may be here, but so it could be here, but it's not going, again, just like what I'm telling you, it's not going to get the exact midpoint. It's going to estimate. So it's not going to get the exact half of this part over here. Um, it could be on this part. The main point here is interpolation search. Make sure that the range would be as less as possible. So chances are the range would be as short as this one. Okay, a better way to explain interpolation search is the way a human being searches for a value in dictionary. So for example, you have a dictionary here. This is your dictionary. Okay, and example, this is your dictionary, a book. Okay, now for example, you are going to look for the meaning of the word, let's say computer. If you're going to open this dictionary, or chances are you are going to estimate, okay, you are going to estimate the location of the word computer at the first few parts of this book, okay, because you're kind of estimating where exactly this word appears on the dictionary. So the chances are the word computer appears on the first few half of this dictionary. But if you're going to, let's say, I'm going to look for the word zoo in the dictionary, I will be opening this dictionary book, or this book, near the end of this book, somewhere at the end of this book. So that's how you perform interpolation search. That's kind of the inspiration of interpolation search in searching algorithms. Okay, so you are kind of estimating the location of the key value in the range, but the goal is you have to the range should be as less as possible, and that's because the goal of interpolation search is to perform search faster. Okay, now if we go back to the three, if we go back to, sorry about that. Okay, okay, if we go back to the three searching algorithms, which do you think is the fastest that will be that performs a searching algorithm? Well, actually, it depends on the range of values that you're looking for. And if let's say the value that you're looking for is small, you have small values, or you have small range of values that you're looking for, then linear search would be good because it performs the fastest. But it depends on the situation. So for example, I have values. You are looking for 6 values, for example, in a linear search, then it will be fast. The linear search will definitely perform best here. But if, let's say, you are looking for 1 million values, you're looking for a key in this 1 million values, then it will become fast. Linear search will perform best if the key value is found at the very first index. Okay, so let's say I have here an array, and we have index 99999, for example. But if the key value appears fortunately at the very first index, let's say at index 0, then linear search performs best. But the further the key value is away from the first index, linear search performs the worst. So you may consider linear search in your application if you're dealing with, let's say, a very small range of values. Now, for binary search, definitely it performs faster than linear search, regardless of where the value is. But again, you have to remember that whenever you perform binary search, the values should be sorted. Okay? Interpolation search, between interpolation search and binary search, definitely interpolation search performs better than binary search. But again, there is a catch in using binary search and interpolation search. They may be performing well in terms of time, but in space that they consume, or in computing space and computing resources that they use in performing searches, they may use more computing resources than linear search because of the codes that they consume, or the codes that they need to perform the kind of search that binary and interpolation performs. Okay, so I hope you have a clear understanding of these three common and popular search algorithms. So I'll see you in my next video. So for now, goodbye.